So now 2 experiences from the field, or more to say, more experiences from the field, the Modular Harvest System and the positive implications for fish welfare. From New Zealand and the Netherlands, please welcome Martin de Beer, Precision Seafood Harvesting, and Pierre Molenaar from Wageningen Marine Research.
Thank you. What do I need to do? Hit? I'm technically inept.
Take this one away, because this isn't yours, right?
No. That's Tom's. I better not steal his thunder again.
Let's see.
No, not that one.
No. You are yours. Let's see now. Your name was...
Oh, yeah. Martin. Yes.
Yes, there we go.
Thank you.
And then we just share it.
Very good. Yes, right. Well, thank you, everyone. I'm Martin de Beer. I'm from Precision Seafood Harvesting Limited, all the way from New Zealand, so I hope you can cope with the accent. Thank you very much to Mike and Michelle for inviting us to speak. I feel very privileged, in fact, actually, given there's 58 different types of fishing gear and everything else that we've been singled out to give you a little bit of an insight into what we've been doing. So I'll switch on. So just very quickly, in terms of who we are a joint venture company between 3 of New Zealand's largest seafood companies in New Zealand, Sealord Group, Sanford Limited and Moana New Zealand. And our 4th shareholder is a government-owned Crown Research Institute, Plant and Food Research. So it's been basically right from the start, it's been an industry science-driven collaboration in terms of the development of our technology. So what am I talking about? We have this thing called a modular harvesting system, and as they always say, I guess pictures speak louder than 1,000 words. So I will show you a quick video that'll give you a little bit of a background as to how it all came about. Should be some sound.
An intimate collaboration between the New Zealand seafood industry, who want to do things better. It started with government-funded research into reasonably fundamental issues, and that followed through industrial applied research, and then prototyping, all the way through to the current program, PSH. We basically wanted to see where the benchmark was for hoki. Problem being is that they're between 2 and say 800 meters down, and we really didn't have any eyes on the problem. So we designed and built our own underwater cameras and had a look. And I think the aha moment was really, why do we have to strand these fish out? Why do we have to exercise and exhaust them? Why do we have to damage them? And we were sort of going, well, there must be good reasons. People haven't fished for 150 years with these methods for nothing, and the more we looked into it, the more we found that there weren't any real good reasons as to why we couldn't fit the in-trawl conditions to the animal. And we developed some concepts and prototypes and basically maintain as low a level of fatigue as possible. We ended up showing that the juveniles and fish that were coming into the catch were actually being selected out. One of the objectives is to make sure that any animal that does actually reach the surface, if we can't select it out in the gear, is actually delivered back to the sea, basically unharmed. When you realize that you can design highly selective trawl, you're winning in many different ways. You're winning in unexplored properties, values that we haven't realized. You're producing a humane harvesting system so that the animals win. I think just a great story.
When we first started trialling, I was a total skeptic, thinking this is just a load of rubbish, but I've completely changed my mind.
What we're actually finding now is that some of the fish that's coming up, the crew are struggling to understand them because they're not what they expect.
We can release juvenile fish, we can eat better quality fish. The net and harvesting technology is really just the start of the process. This will lead on to changes in the vessel designs and layouts, how we handle fish and get it into the marketplace. Really, the opportunities are endless.
This, ladies and gentlemen, is the future of commercial fishing to me.
So what am I talking about? So what we've called the modular harvesting system is a membrane-based technology. So it no longer uses mesh, and it is designed to replace what you would call the cod end and what in New Zealand we call a lengthener, but I think you call an extension up here in terms of a typical trawl. So the idea is to tailor the in-trawl environment to more closely match the physiological tolerances of the fish, and also maintain the vitality of the catch until it comes on board. So how does it work? It comprises 3 different modules, which is shown in this diagrammatic representation: a cone module, a series of retention modules, and a lift bag. So what does it do? The cone is a non-porous module at the start, which is attached to the body of the trawl, and that enables the MHS to deploy and set correctly and maintains the hydrodynamic stability of the unit whilst it's during fishing. The retention modules are semi-porous modules that contain apertures which act to reduce water flow, creating a low flow, low turbulence environment within the MHS and provide for escapement of non-target catch, i.e. undersized or incidental catch. And finally a lift bag, which is a non-porous module, which is designed for the fish to remain in water when hauled on board, reducing physical crush on the catch. So the arrows show the water flow, and this is part of the development of the system. As you can see at the front end, we're represented by the 3 arrows. Water enters the module at tow speed, maybe that's 4, 5, 6 knots, depending on what you're doing. And over the course of the retention modules, that water flow is reduced gradually down to almost static at the lift bag end. And that creates that laminar non-turbulent flow that you see within the environment and allows the fish to regain station and regain control. There's just a few pictures just to show you in terms of we've been working collaboratively with Varga Ninja Marine Research and some trials we did on a beam trawler, but this is just to show you what it looks like in reality on a 4-metre beam trawl with the body of the mesh trawl then transitioning into our MHS gear. So I'll quickly flick through those, just to gives you an example of what they look like. So what does it do and what can it provide in terms of sustainability to fishing operations? Firstly, in terms of catch welfare. Secondly, in terms of quality. Thirdly, benefits in terms of selectivity. And lastly, benefits in terms of survivability. I'm going to talk mainly around, I guess, the catch welfare aspects, but as you all know, these elements are all intrinsically linked. So, in terms of catching fish unharmed, I'm going to show you a little bit of video footage just to compare environments and to give you a bit of an example of what we're talking about. Oh, sorry, it didn't play for some reason. You able to get that to play for me? No? Oh, got it. Okay. Thank you. Sorry about that. So just to show you, this is a typical mesh cod end. As you can see, turbulent environment. The fish occur in a washing machine type environment. You encourage fish-on-fish contact, fish-on-gear contact. Contrast this to the environment within the MHS. As you can see, the low-flow, laminar turbulent, non-turbulent environment allows the fish to regain station, individualise and exhibit normal schooling behaviours. What does that look like? A couple of examples. This is from New Zealand Fisheries. The top shows the mesh cod end versus RMHS. As you can see, on the left-hand side is for what we call snapper, Australasian snapper, and on the right-hand side is our hoki or blue grenadier. Again, you can see the bolus in the typical mesh cod end. The fish end up being crushed and compacted and cannot move around. Contrast that to the environment within the modular harvesting system, where you can see the separation. A little bit harder to see within the hoki trawl. Hoki tend to school in a bit of a rolling ball, but you can see still there the fish are able to move around and less compaction. What does that do in terms of the quality of the fish? I think the pictures show it all really, but on the left-hand side you can see from a mesh cod end versus on the right the modular harvesting system. You can see the colour, the difference in terms of scale loss, fin damage, and just the whole change in terms of the environment for that fish, and therefore the quality that comes through as a consequence of how that fish is treated within the environment. Just moving on to that a little bit further, we have a bit of a study that's currently in publication, looking at the short and long-term survival condition of juvenile Australian snapper, and in terms of the degree of damage and behavioural reflex impairment of fish landed within the MHS versus a marked mesh cod end, and we've found there to be substantial differences. So these were fish being kept in the tank, as you can see from an MHS trawl. They are relatively still looking relatively undamaged, swimming around, and relatively healthy. Compare that to MHS caught fish that's then been retained in the tank. As you can see, the colour, the scale loss, just a very different beast through the different environments within the in-trawl environment and the different gear types. This just was to show you some of the results from the study. Survival in terms of the MHS compared to mesh cod hens was significantly different, both at time of landing, 48 hours post-landing, and then 300 days after. You can see there that we had differences in levels from 96% versus 86% at landing, through to 84% versus 27% at post-hour half, 48 hours post-landing, and 300 days levels of 86% versus 53%. So the long-term monitoring showed mesh cod ends induced high levels of abrasive damage, leading to fin erosion and reduced growth, but not so within the MHS. A little side project that we're working, which I just thought I'd talk to you about as well, is that we have developed an ability to release the MHS at depth. This was originally designed around the protection of protected species or vulnerable species in New Zealand, such as marine mammals, dolphins, sea lions, and seals. And so, the idea that we could release the net at depth where there's an animal that's entered the net and allow that animal to escape. And at the same time, given that the fish remain alive at depth, there's no harm to the fish populations either. So we have tested a prototype in New Zealand, which has been supported by the New Zealand government. And I'll just show you a quick video to give you an example of what that looks like. So this was just testing it without any fish inside, just to show that when we opened it up at depth, that the MHS remained inflated and did not collapse, so ensuring there was an environment from which the protected species and fish could escape from. And that's just showing it back up through the forward end through the series of retention modules. Once it's opened, there is some change in the stability of the modules, but overall it remains inflated. This was a test looking at spiny dogfish in New Zealand. So these were released, school was caught, and then the MHS was opened. As you can see, those fish remain in healthy and good condition. And once they've experienced the initial change in water velocity, they right themselves and are quite happily swimming away. Just another brief example I'll just come into in a minute, just from our mixed demersal fishery in New Zealand, you'll see. So this is a fishery with snapper, skates, flatfish, combination of species, typical mixed inshore fishery in New Zealand. But again, you can see the fish all remain healthy and viable when released. So as I say, when we can detect a protected species entering into the trawl environment, we can open this at depth, the fish are alive, and the marine mammal can swim away to live another day. There we go, I'm on time. Just to let you know where we're up to now. So our technology has been patented in 30 countries globally. We have regulatory approval in New Zealand to target 3 deepwater species and 11 inshore species. We are currently just working with the New Zealand government around extending that approval to allow access to all New Zealand fisheries. Currently, it is only being used by our shareholders across 10 vessels because we're not in production. We're still in an R&D phase. And we're just embarked on a new 3-year investment program of around about $9 million New Zealand dollars to further develop the product, look at trialling in different jurisdictions, particularly internationally, so we can see where those benefits from the technology could be applied, and then look into manufacturing. In terms of the project, well, it took us 7 years to get it to a point of being able to be commercially used. It was a co-funded joint venture between industry and government of 50-50 funding between the parties. And so by the end of the program, we'll have spent approximately around about New Zealand $50 million in funding and carried out over 10,000 experimental tows in developing this technology. So I'm going to hand over to Peki next, who can give you a rundown as to how it's actually worked in reality in terms of the trials in the Netherlands. Thank you.